Right. Okay. We are ready to go. So I've changed the frame slightly so I get the whole slide in. Okay, let's make a start. So today we're going to talk about pipelines and pipeline cleaning and deposition prevention. So they are the two things really this unit is all about. The unit numbers are 4.6 and 4.7. So that's on the unit 310 for thermodynamics. Big question is, what has this got to do with thermodynamics? A little bit. There are a couple of elements. One of them is that pipelines tend to clog up when the stuff that's pumped through gets hot and gets cold. So it's maybe warm, like crude oil is pumped in warm, and then on its journey through the pipeline it cools down, and then the deposition starts. And once this is happening, obviously there are two things. One of them is to clean them, to make sure the pipelines are free to flow, and also to prevent from deposition to actually occurring or take place. Okay, first of all, we need to look at pipelines. The presentation is not going to be that long today, so we'll just have about maybe 45 minutes, I reckon, and then we are done. It's just a little bit about pipelines, a little bit about the methods, how to keep them clean, and how to prevent deposition, and we are done. Okay, and so just to mention how we carry on from here, I think most of the classes are going to be here after half-term break. So we then going to focus on exam preparation, and we cover whatever is missing or whatever you're not sure about, to make sure you've got all the knowledge you need for the exam. And then we will, if there's anything missing out, we will sort of carry on with that. But that today, is the preliminary end for this particular part of on the online sessions. I'll send an email out just to confirm this. So if next Friday or so you try to get on here, unless something comes up or you feel you need to do something or cover something, we will not have a session. Okay, make a start. So you can see some pipelines here, just to sort of talk a little bit about this. So this one is somewhere in a factory, and again, that's probably where you find most pipelines and where most of the technologies we are talking about here, where they're actually applied. But you also find pipelines in places like Alaska, or there's now a massive pipeline called Nord Stream 1 and Nord Stream 2 in Europe, which comes from Russia all the way into Central Europe. And here, I think this is part of the Alaska pipeline. You can also see some things here. One problem with pipelines is the thermal expansion. And obviously, if you've got a structure that's a couple of 100 miles long, the expansion on either side is going to be quite massive. So you find that often they put these bends in these pipelines to absorb some of the expansion which takes place. But there's also a problem, and that's what we are talking about today. And this is all about deposition. When we've got a pipeline that dirt and grime can sort of get stuck in these corners here. And that's what we're going to look at and how you can prevent this. Okay, let's go to the next slide. At the end of the session, you will know methods of preventing pipelines getting clogged up and methods of cleaning pipelines. Yeah? So we're just talking two of them. And they're pretty much just two for each. And we could have all done and dusted in a couple of minutes, but you need to understand the problem you have with pipelines. Okay, next one. I've got some messages here. By the way, feel free to type. Right, you can't hear anything. I'm just looking at the messages. Some you can hear, okay. Corey, I can see that your phones are not connected, your headphones are not connected on the thing here. Try and see whether you can put some headphones in or something. What am I doing, huh? He can't hear. Just type to him. So I'm just typing to Corey to sort of try and get him online. Okay. Right, I'll carry on. A couple of questions. Where are pipelines used? What do they carry? And what are the issues pipelines have to deal with? Okay, just give you a couple of minutes to give me some answers if you can type them in here. Okay, carry ingredients. So that's what pipelines are used for, yeah? Thanks, Callum. Oil and gas, some. Yeah, pretty much that's probably the widest use for pipelines. I'm just looking at one of the problems is corrosion. That's a big issue with pipelines. Okay, thanks, Corey. It's working fine now. Okay. Use between machinery as well, yeah. So that's a big thing in factories. So thanks for the answers. Any more answers? You know, where are pipelines used? What do they carry? What are the main issues pipelines have to deal with? Yeah. Corrosion is a big one. Leaks as well, you know, good point. Big issue with, thanks Brett and Callum, leaks is a big issue for pipelines as well, yeah, to control them. There's some really interesting sort of pipelines out there. We're going to look at the Alaska pipeline and, as I said, like Nord Stream. They're two very different concepts, very different stuff which is carried with them. But it's quite interesting when you look at them and when you read up, about it and see what problems they're dealing with. Okay, let's move on. Yeah, thanks for the contribution, guys. Right, go to the next slide. Yeah. Examples where pipelines are used. So we've got sewerage systems. It's just one example. I have to talk about this because I used to work on a sewage farm, which I'm sure I've mentioned about 100 times, and you're well aware of it. But sewerage is one, yeah, where pipelines are used. And I sort of remember working at a pumping station, and there was a big pipeline of sewage, which was pumped from a lower point to the main sewage plant. So there was a low point somewhere, or the sewage system was sort of fed to this point, and then it was pumped back up again. I dread to think what would ever happen if the pump fails, yeah, and all the sewage just accumulates at this low point. But yeah, anyway. Then we've got oil pipelines, like you said, and we've got from ship to shore, yeah. So we've got like little like ports and things like that where ships can, dock, and then the oil is pumped from ships to a refinery or something. And then we've got pipelines from oil platforms to shore. Yeah. So that's another one. North Sea. I wanted to sort of have a look at a little bit what's happening in the North Sea now. I know some of the gas fields are pretty much empty now, and they're using the gas fields, that's what I've heard, in the North Sea. Instead of extracting gas, they've got all these stratas in the rock where they can store gas. And so what's happening now is it's like a big business. They buy gas on the world market when it's cheap. They pump it into these gas structures, into these stratas, these stone stratas where the gas is stored. They store it there. And then when the gas price goes up, they extract it again and sell it at a higher price. So that's one of the things which is happening at the East Coast right now, where like on the other side of Hull, up here, where we've got like the terminals for gas. We've got hot water and steam as well, so you get them in power plants, for steam, to transport steam. And then when you go to Eastern Europe, a lot of the heating systems, they're all remote heating systems. So they've got a heating plant, a bit like a power station, and sometimes they're combined as well. So you've got a power station, and a byproduct is hot water, and they use the hot water to heat the town. It's quite avant-garde. It's been done since the 50s, and they still do it today over there because the systems are still in place. In between terminals, like some of you said, between factories, and then obviously in and outside factories. So that's just a few examples of where they're used. Let's have another one. What do pipelines carry? We've got oil, gas, water, sludge, steam, petrol, chemicals. And then straight away when we talk about chemicals, some of them are corrosive, some are acidic, some are explosive. Yeah. And these are all issues pipelines have to deal with. And also, if it's acidic or corrosive, it destroys the pipeline from the inside out. If it's explosive, you have a whole other set of other issues to deal with to make sure it doesn't blow up. And obviously we've got stuff like sludge, okay? And sludge can leave deposits on the side of the pipeline. So it's quite an issue to deal with. Okay. Next one. These are the pipeline issues. You can see, I think this one is the Alaska pipeline. You can see somebody walking on them. we're going to go into a little bit more detail there. It's just a tiny pipeline here, where the red dot is. The pipeline issues are, one of them is a thermal expansion, and that's a big issue. When you've got a pipeline, now the Alaska pipeline is 800 miles long. Nord Stream 1 and 2, they are about 500 miles. So they're huge pipelines, and when you get a change in temperature, and in Alaska you've got quite big changes. I think in summertime it can get to about 20, 30, sometimes even 40 degrees in some parts of Alaska, and in wintertime it goes to minus 40. So you've got a temperature difference of up to 80 degrees to deal with, from maximum expansion to minimum expansion. And when you've got 800 miles, I mean, that would be a huge amount. So if the pipeline was laid down in a straight line, it might just go in and out by about, at either side of the pipeline by 20, 30 meters. I'm not sure how much, but quite a bit. And it would, cause huge problems and huge stresses on the steel. So what's happening is they put some bends in the pipeline to pick up the stretch or the thermal expansion of the pipeline. So every couple of miles you've got some sort of U-bend in there to pick up any expansion and to deal with that. Problem is, whenever you've got a bend, you've got a problem with deposition of materials. So stuff can get stuck in the bends. Right, what else have we got? We've got corrosion. Corrosion, like some of you mentioned before, it's a problem. That's from the inside of the pipeline, but also from the outside. I mean, most pipelines are made out of steel. And then we can look at the next one. Some of them are subterranean, so they're buried in the ground, which means you can't really control them that easily. So you've got a pipeline in the ground, and you don't really know, what the state of the pipeline is, whether the corrosion is to a point where you need to do something, or everything is fine. And then you've also got submarine pipelines. Submarine pipelines are on a seabed, and again you've got salty water. There's an aspect of potential corrosion as well, but there's also corrosion from the inside as well. With subterranean pipelines, you've got other issues. If the earth moves, you've got a landslide, or you've got leaks. Dangerous stuff can leak out. If you've got a landslide, it's a problem as well. Yeah. Right, what else have we got? Residue built up. Yeah, that's what we're talking about really today. Deposition of stuff, clogging up. Then we've got contamination of the pumped medium. There's some pipelines, and I meant to dig it out, but I leave it to you. Maybe it's a little bit of homework. There is a pipeline which goes from, I think it's from Immingham all the way to Penniston. Penniston is just outside Huddersfield here. And I understand that the pipeline is being buried in the ground, but it's sort of a tanker terminal for petrol stations. So, the Jet and Esso and Texaco tankers, they go to that particular terminal and they pick up the fuel, and then they supply the whole region around here. So they don't have to drive all the way to Immingham, which is near the coast, but they can do this all locally, and the fuel is pumped through. And anyway, so and the thing is, they've got different types of fuel they use the same pipeline for, and I understand that they've got some really interesting systems where they've got some slokes or something to separate one fuel from the other as it moves through the pipeline. So some very intelligent systems in there. Might be interesting to look into that as well, and it obviously affects the whole question of deposition and things like that. Okay, we've got hot liquids and gases cooling down. That's a problem as well, and that's where all the clogging stuff comes into. So if you've got a hot liquid, the viscosity, so that's how liquidized it is, or how fluent it is, the viscosity goes down. Yeah? So that means it becomes more stiff as a liquid, and that means there's more chances of stuff getting stuck in the pipeline and being deposited, and that's one of the big problems. So what we need to do is we need to keep the pipelines warm. We need to keep the liquids in there warm, especially if there are solids inside the liquids, so that they don't deposit. Then we've got depositions, impurities or materials. Yeah? So we get crude oil. There's all sorts of stuff in there before it's refined, and it's an issue. And then obviously the last one is frost as well. Especially when you look at Alaska, you've got minus 40 degrees. I know in Alaska when they've got trucks, in winter time, they never turn the engine off because they know when they turn the engine off, they will not be able to start it until springtime. It's so cold out there, or until the temperatures rises up, to do with the way the diesel behaves in cold temperatures. So it's quite interesting. So they keep the cars running literally, throughout the cold period or the coldest days without turning the engines off. Not cars, but the trucks. Okay, I've got some pipeline examples. I've got a couple of pictures here. I don't fully remember where they are from, but it gives you sort of a bit of an idea how pipelines are put together. Let's go to the next slide. One is the Alaska pipeline. Now, Alaska is the northernmost state of the United States. So you can see a bit of the border here. On the other side is Canada. And there's now a direct link from mainland United States to Alaska. So they either have to drive through Canada or they have to go by boat. So it's really far north. The North Pole is not far off here. And there are even living people. You know, there are Inuit people traditionally who live right at the northernmost part of the coast. And most of the people live down here. I think Anchorage is down here somewhere. And in the whole of Alaska, I think it's only like 200,000 people. So it gives you an idea of what the state is all about. But what they found is they found huge reserves of oil. And they've been, pumping oil and getting the oil moved from various parts, where they find and where they extract the oil, right to the south. In the south, they've got a port which is open most of the year, so the water doesn't freeze up. And from there, they can export the oil and they use it for all sorts of stuff. Now, this is some information about the pipeline. It's 800 miles long. That's 1,300 kilometers, about there. The diameter is 48 inches, so it's 1.2 meters. Yeah, so you couldn't walk through it, but you could comfortably crawl through it. And you can see a picture here as well. So that's a little, not sure what they're called, like a reindeer type of animal, and you've got a picture of the pipeline as well. Now, the pipeline is not put in the ground. I think one of them, it allows for inspection as well, in case something goes wrong. But also the pipeline is very remote. I've sort of seen some pictures or some photos where they ask people not to climb on it because they could injure themselves and so on. But it just sort of illustrates how remote the pipeline is, and they can't possibly guard it all. But then again, there are hardly any people in Alaska. There's only about a couple of 100,000 people living in Alaska. So it's not that much of an issue. Some pictures of the Alaska pipeline, and you can see some of the bends as well, which I think are put in deliberately to deal with the thermal expansion stuff. So if they expand, they just move the bend a bit further out. You can see this here as well. So if it expands, it would move it a little bit further out. But so the stresses are going to be not across the whole pipeline, but only in some sections of the pipelines, and they give some enough place to move in there. That bit down here is quite interesting. So what you see is a lot of wooden bars, and the pipeline is actually loosely laid onto this surface, and the reason is it's a fault line. So you've got tons of earthquakes there. So as soon as you put any rigidity into the pipeline, it'll actually crack. There's a danger that it could crack. And so as far as the fault is concerned, they've got some very flexy type of system. So if there is an earthquake, it'll just shake a little bit, and then it'll sort itself out. Yeah. So that's the theory behind it. You can see a bridge here for the pipeline, so they try to cover some creeks. So this is all pictures from the Alaska pipeline. And here we get to the cleaning bit. Yeah. That thing is actually called a scraper pig, little piggy. They stick it in the pipeline, and you can see those things on the side here. They are the cleaning element. So they push some liquid or something behind it, and that scraper pig just moves through the pipeline and tries to fetch off all the dirt and everything else. Now, if the bends are not too tight, it'll be able to go through a bend, and I guess I would say it's going to be picked up at a station further down, and then it's going to be removed from the pipeline. But yeah, that's what they use. That's one way of cleaning them. We're going to look at another way as well. There are only two ways for either one of those two. So that's a scraper pig. Okay. The other one is this a big project, and you probably heard about it in the news. Donald Trump isn't very happy about it, or the Americans in general. And the worry is that there's too much of a reliance on Russia as far as gas is concerned. Okay, now this is the former Soviet Union, and we've got Russia here, we've got the Ukraine here, we've got Belarus here, so that's White Russia, and then we've got the pipelines going to Europe. And the Soviet Union has been giving or delivering gas to Europe for many, many years, even in the Cold War, and most of the gas went through the Ukraine. Now Russia and the Ukraine, they are no longer friends and pretty much enemies, and Russia demands the full price for the gas from the Ukraine now, and in olden days it was sort of sold at a discount. So the Ukraine controls a pipeline on their territory, and what they did is they allegedly, I don't know, it's just what the Russians accuse them of, they were siphoning off gas for their own industry, for their own consumption, and then not all the gas they sold to Europe was actually going to Europe. And then they were also charging Russia a lot of money for the use of their pipeline through their territory. So that was sort of a problem, and so sometimes the problem between the Ukraine and Russia affected Europe as well, that gas wasn't coming through. The Russia thought they have to do something about this, and to do this they built two more pipelines. One of them is Jamal, and that's a pipeline here. Don't know whether you can see the red dot here. And you've got this Jamal pipeline, which moves gas to Europe, so they can bypass the Ukraine and they can still get in the European network. And then they decided to lay another pipeline directly from Russia, because here they have to go through White Russia and Poland. Whoops. White Russia and Poland. My phone is just going off here. There's White Russia and Poland. So it has to go through White Russia. And it's another country as well, so they've got a problem. So they decided to build a pipeline right through the Baltic Sea, all the way from Russia, that's St. Petersburg up here, all the way from Russia to Germany, and then in Germany it would enter the European net, and even going all the way up to Britain. Yeah. So that's really the project they have. Now, they've got two pipelines. One is called, you can see this here, Nord Stream 1 and Nord Stream 2, and to move tons and tons of gas into Europe. Again, politically, it's very loaded. Yeah? So you've got the Americans who don't like the idea, but then there's no real alternative, because buying gas from America could only be done by a ship. There isn't a pipeline long enough, and it probably wouldn't work that well either if you put one down in the Atlantic. But the distance is too long, and there's too many problems with the pressures and everything. So that seems to be the only option, to go from, move gas from a gas-rich country like Russia to Western Europe, which is in demand, which needs gas. Okay. Just to sort of illustrate how important pipelines are and why we have them. This is a Nord Stream 2 project. I've got a couple of pictures here. That is not an oil platform, but it's a pipeline platform. So it's halfway submerged. And they weld the pipelines together. You can see the worker here who is welding the pipeline. This is what the pipeline looks like. So it's got some sort of armor on the outside, corrosion protection, and here's the lip where everything is welded together. And then they lay the pipeline on the seafloor. It's a big map as well, so you can see where all the gas comes from, sort of from the the vastness of Siberia. That's where the gas is collected, and then it's pumped all over Europe. Okay, so it's very, very important, and probably Europe wouldn't work today as well if it weren't for the supply of gas from Russia and other places as well. Bearing in mind that, for example, North Sea gas has shrunk an awful lot. I'm not sure how much is still there, but it's not as much as what it used to be. So the gas fields there are sort of depleting slowly. There's still Norwegian gas, but similar as well. So I understand it's depleting as well. So now we buy gas from Russia. The problem of deposition. Just have a look at these pipes here. You can see, how bad it can get. So these are all little pipelines, and there's a lot of deposition in there. And obviously they haven't been cleaned probably for the length of the lifetime. So we've got foreign objects in liquid and gas, yeah, and they can get deposited. We've got chemical deposition, so sometimes you get a reaction between the pipeline wall and whatever you're pumping through the pipeline, and it just sort of settles on the pipeline itself. You get pipeline corrosion. You get deposition due to cooling, yeah. And then you've got bends and floor breaks, which are there, and like valves and things like that, and deposition could happen in the bends or wherever the flow breaks are. Okay, move on. Methods of preventing deposition, and that's really, what this lesson is all about, and we are probably making our 45 minutes aim. We've got steam tracing, electrical tracing, and then a steam water jacket. Okay, so that's preventing deposition. The whole idea, again, you can see, the deposition takes place. And just to give you an example where this comes from, when I was working at the steelworks, if you worked there for, I don't know, for an hour, you were covered in dust and steel dust from top to bottom. Today, probably not as bad as what it used to be about 30 odd years ago when we didn't have sort of extraction system or air extraction system, so they weren't required or compulsory. You just dealt with the dust. But it didn't take a long time, and you looked like a miner, from the coal face. And so when you wash your hands, you got like a lot of grime and grease on your hands as well. It got off, and one problem we had, it was always clogging up the what is it called? The outlet pipe of the sink. The wastewater pipe of the sink, that's it. And it started clogging up all the time. And I sort of remember one of the old guys telling to me is all they need to do, and he was sort of mourning at the management, is just get warm water supply restored. Yeah, there was a little warm water tank, and that was broken, and somebody had to fix it. Nobody did it. And as soon as they fixed it, he said it would go away, the blockage in the wastewater pipe would just clear off. And true enough, I mean, eventually it got fixed, and you could wash your hands with warm water, get all the grimy, dusty stuff off, and it didn't take a long time, and the blockage was gone. Yeah. So that's sometimes the key. Warm water or a warm liquid is less likely to deposit stuff. It's got a higher viscosity than a cold liquid, yeah, with sort of stuff suspended inside the liquid. And so the idea here is with any of these methods, with steam tracing, electrical tracing, and steam water jackets, is to just warm up the pipe to stop deposition from taking place. So that's all. You just warm up the pipe. That's really the whole technology behind it. Let's have a look. These are tracers, so you've got some insulation material around the pipe, and then you've got a small pipe there as well. And the small pipe, all it does is it pumps hot liquid through it. Yeah, hot liquid, hot oil, something. Yeah, just to induce some heat into the main pipeline. And yeah, and that's all it is. Yeah, to start off. Let's look at the next slide here. That's what it looks like. So you've got steam tracing. So you've got some thermal insulation. You've got a pipe here. You put some steam. You pipe some steam alongside the pipe, and that heats up the pipe, keeping whatever liquid you've got in there, keeping the viscosity high, which means there's less likeliness of anything to be deposited inside the pipeline. Okay, that's sort of the method which is used. Right, let me just go through. We're gonna, I don't know which one is more effective. Very good question. Not sure. I would say the most effective one is probably the steam tracing or hot water tracing, more so than the, using the next one. I'll show you the next one before I talk on this. Electrical tracing. What do you think is happening when we talk about electrical tracing? Could be, depending on the product, yes. It's a good point. I'm just reading from the text for the, if you watch it by YouTube, the messages which are coming through, yeah. Electrical tracing, how do you think it works? So we know, steam tracing, or if you've got a hot liquid or something, you just pump it through in a small pipe and you put some insulation around the pipe. And so you induce heat into the pipeline. What would you do for electrical tracing? Any ideas? I'm just waiting for you guys to hit the keyboard. Come on, anybody? Anybody, any ideas? Ah, yeah, somebody's typing, that's good. Right, let's have a look. A conductor to heat the pipeline, pretty much, yeah. That's pretty much all it is, yeah. You get some heat wire, so it has got a small resistance, and when you put sort of 240 volts or something across it, the small resistance will generate heat, yeah. Let me show you what it looks like. But yeah, spot on, Sam and Luke from Tutbury. That's what it is, okay? All you have is some heat wire, and it just, you can follow the red dot here, just goes around the pipe. I can see this here as well. So you've got your power source, you've got your insulated copper wire, and your heat tube. And down here you see a picture how it's implemented for rear, yeah, where this stuff is sort of put around the pipe to sort of make sure to induce some heat. Ideally, what you would do is you would stick some lugging around the pipe as well, which they haven't done here, but if they had, you wouldn't be able to see anything, really. So you would put some lugging around it to make sure that the heat is contained, that you're not heating the factory oil, but that you're heating the pipe. So that's the important thing. This looks to be outside anyway, but that's one way to do this. Interesting as well, when you look at this one here, they put a lot of emphasis around these bends, put like some loops on there to put the tracer on. Okay, so pretty much the same thing. The only difference is for one we've got a hot liquid, the other one is electric. The hot liquid, I think, as far as energy is concerned, may possibly be more effective, but for electrical ones, there's no messing about. You just connect it to a power source. You tape the heating wire around the pipe, put some lugging around it, and you've got it. But you don't have to worry about any liquids or heating up liquids. Or having like a hot water tank where you get the heated liquid from, so you don't have this problem. Okay, steam water jacket, yeah, that's what they look like. It's pretty much just the same stuff you've got on your immersion heater in your home, if you've still got one, where you've just got like some sort of jacket around it to keep the liquid hot. Okay. Just another, I saw this picture and I thought that's quite a good picture for a pipeline. It looks like sewage to me, I don't know whether it is, but this is completely clogged up. Yeah. This is sort of the reality, so if you don't deal with this, it gets cold, it hardens, the viscosity goes down, sticks to the wall, and it gets worse and worse, and eventually it's completely clogged up. Yeah. Okay, next one. Pipeline cleaning. Yeah. We had a look at a pick, and the pick goes through the pipeline or is pressed through, and it's just all it is just pushed for by the liquid behind it. So you stick the pick in the pipeline, and behind the pick you would have the liquid or the gas or whatever it is, and that would push the pick through the pipeline and at the same time start cleaning it. So you've got some scrubbers here. Notice as well you've got some scrubbers here on the side. I don't know whether they can make out those brushes. They are brushes. And they would sort of go against the wall and try and scrub any sort of finer stuff from the pipeline wall, and is pushed through. I would think there must be some sort of pick stations where you take the pick out of the pipeline, so you can turn off the pressure, can open the pipeline, take the thing back out again, and take out whatever the pick's picked up, yeah, and pushed along the pipeline. But it's a big challenge. It's a really big challenge. You've seen, what some of the pipelines look like before. Let me just show you again. Yeah. Look at this pipeline here. One thing you know for certain, there's not been a pick through it for a very, very long time. There's been no cleaning taking place, and the pipeline is de facto useless. Okay. I just see somebody's typing. Brett Cullen. Okay, the pick's pushed through the pipes with the liquid behind it. Let me just show you. Go back to the first picture. Good question, very valid question. Because you think, what's happening? Oh yeah, here we go. You can see this a little bit here. So you've got some, it's a bit like what? Like hollowed out at the rear. So the liquid is pressing, you see the point, the liquid or the gas will be pressing behind it, and it will push it through the pipeline. So there's nothing other than the pressure of the medium you're trying to push through the pipeline. There's nothing there. So there's no motor or anything like that in there. It would be a nightmare as well if that thing gets stuck anywhere in the pipeline. You would have to literally cut it open, get it out. But it's just pushed through with the liquid behind, and over here it looks a bit like a bullet, doesn't it? Like a massive bullet. And then here at the front you've got the thing where it goes through. And then on the side, these are the scrubbers. So these scrubbers, they try to clean any deposits from the wall and pick them up somehow. But yeah, it's just the pressure of the medium, the liquid or gas inside the pipeline. Let's go forward. We're almost done here, so we might even stick to our 45 minutes. That's what I thought it would take. Yeah, okay, this again, you can see some scrubbers as well. And again, behind this pick, you would have some sort of indentation for the liquid, the oil, the gas, whatever it may be, to take hold of the thing and push it through. The pressures can be quite high in those pipelines. Okay, this is brushes. I should put an R in there. That's just a pick with brushes on the side, and it's just to pick up sort of smaller stuff, possibly for a gas pipeline or something. So where some scrubbing takes place as the pick is shot through the pipeline. And then we've got pipeline cleaning using solvents. Yeah? So I'm not quite sure how it's done and how they do this. I'm going to show in a minute where pressure is used, jet pressure is used to clean a pipeline. It's probably more suitable for the stuff you find inside your factories, where you might put some of the pipeline cleaner into a jet pressure washer, open the pipeline, and then you clean it. But again, when you look at factories, you're probably looking at a pipeline length which is a couple of 100 meters maximum. When you look, at commercial long distance solutions, I don't think pipeline cleaner or solvents would be a feasible method of cleaning the pipeline. I'm not sure. Maybe you could put some of it in the pig, and as the pig is pushed through, some of the solvents are used to clean the walls. I don't know whether there's anything like that. I could imagine that there might be something. But sort of within a factory context, that's certainly feasible to put some pipeline cleaner in there and to keep them clean. By the way, they recommend this as well for your central heating system. There's a lot of sort of sludge picked up over the year, especially if it's a closed system, through corrosion and other stuff. And they always recommend that you put some chemicals in there to keep the central heating system well flushed and not to have any residue built up anywhere. Okay, next one. And this is a jet cleaner, pipeline cleaning, high pressure jet. And again, we are looking inside the pipeline, into the pipeline, and you can see there are these wheels, and then there's some jets there, and we've got the water feed, which just follow the red dot. Yeah. And that water feed would, go through and, blast any dirt or anything away. Now again, I mean, this is probably useful within a factory context. I mean, when you look at the Alaska pipeline, I doubt whether you could afford the time, or it would, engineering-wise, be possible to have a setup like this where you push something like this down for 100 miles or something. It would take ages to do it. And so I think for pipelines like in Alaska and for Nord Stream 2, which is probably about 500 miles, you wouldn't do that. You would just have like a pig of some sort or another to try and keep the thing clean. And yeah, we are at 45 minutes. It's just a summary at the end. So first of all, pipelines carry different materials, which we looked at. And depending on the material pumped, pipelines can get clogged up. So maybe with gas is less so, but when you have sewage, there's a good chance that it gets clogged up because of all the stuff that's in there. There are ways through heating the pipeline to minimize any deposition. I missed a word here. There are ways through heating the pipeline to minimize any deposition. So again, you should heat the pipeline, but how it's done in real life, I mean, the sewage plant I worked, there was some some lagging around the pipelines. I've seen that. Yeah, there was plenty of lagging around it to try and keep the temperature that's in there and keep frost out, especially with the water contents. But when I was talking to the veterans of sewage work, and I was asking them what was happening in winter time, whether it would ever freeze up and then the whole system wouldn't work, and they said no, because most of the water is warm anyway. It comes from a domestic environment and gets heated up with the the temperatures in the house, and in wintertime, even when it's really, really cold and you've got minus degrees, and it always seems to be about 4, 5, 7, 6 centigrade, even in the worst of winters. So the temperature never goes really cold to the point that it freezes up. But again, I haven't seen any heating in the pipeline, any systems for heating the pipeline at the sewage plant here. I'm sure that a lot of factories will have this, and again, it's always, if a pipeline gets clogged up, it's a massive production loss until you get it back going again. If there are depositions, they can be removed with pigs, solvents, and high-pressure water jets. Yeah. So again, from what I can see, it's probably just the solvents and the high-pressure water jets is just a solution for factories. Pigs, scraper pigs, probably for big pipelines as well. Especially if it's like crude oil and things like that. A lot of stuff gets sort of, picked up with crude oil, and it might be deposited on the pipeline wall. So you need a pig to try and get rid of this stuff and pick it up. Okay, that's it for today. That's the the summary on pipelines. As far as thermodynamics is concerned, it's just a concept, really, to just bring it into context. That viscosity is affected by heat, so that's where thermodynamics comes in. We need heat to keep the viscosity up, make sure that the liquid stays a very good liquid and is very fluent, and that's what the key is to do this. Yeah. I've got another message here before I close today. Let's have a look. Are we going to have lessons when you will be at the college? Yes, yeah. The lessons after this are the lessons after this will be just exams. We've got about 5 weeks. The exam is going to be week 3. So in case you fail, you've got a chance to reset it. Yeah, at the end of the block, but not right at the end. We need about 1 or 2 weeks before, for me to allow to mark it, to feed back the grade to you, and also for you guys to be able to reset it in case you fail, you don't get a pass. Okay, but that's the reason why we've done these sessions here online. Yeah, so we need to make sure that, or I need to make sure that. All the theory is covered, which I think we have now. If there's still something missing, we're going to pick it up in the first couple of weeks, and then we just spend about 2 weeks on exam prep. Then we're going to do a mock exam, then the real exam, and then we've got reset time. Okay. Any more questions, guys? When you come back, I think you're here for 5 weeks. It's going to be week 4 when the exam is. Week 4. I don't know what the date is. I would have to look it up. Just count the number of weeks. I think you come here in 2 weeks' time. Is this right? Don't worry about it. The exam is not that hard. Yeah. All I want to do is just concentrate on the knowledge you need to have. So, and we've covered the lessons. The knowledge you need to have for the exam, sort of about 70% ties up with the lessons, and then the rest we're just going to cover it when you come in. Yeah, so don't worry about it. Guys, I need the names of everybody who's been listening. Can you just type them in? So if I can see Brad Callum, I can see Corey, Luke F., I can see some Luke from Tutbury, and some Gibson. If anybody else is with you, can you just type the name in? Just for me, for the register. Okay, I'm going to stop it here for the recording for the YouTube channel.